Okay. So far we know one kind of shortcut to prove triangle congruence, and that is angle side angle. All right. If we have two angles and the included side, that is the side between those two angles, we can show then that the two triangles will be congruent. All of their parts will be congruent, not just those pieces. Well, we have a similar rule with side angle side. So now if we know two sides of a triangle and the angle between them, then we know those two triangles will also be congruent. Okay? All three angles and three sides of one triangle will be congruent to all three angles and three sides of another triangle, just if we know that two sides and an angle between them are congruent. So we have angle side angle now that we can use to prove triangles are congruent. We have side angle side. All right? This is a little activity or something like that they wanted you to do to actually show that. We're not going to worry about that. We'll just move on here. Okay? So, let's first of all, just like we did before, right, we talked about deciding whether triangles are congruent using side angle side congruence. Okay? So, side angle side again, I'll just read it out here for you. If two sides and the included angle, that's the angle between the two sides, of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Right? So if we look here at our picture, all right, determine whether the triangles are congruent, explain your reasoning. So looking at our picture there on page 247, okay, looking at our picture there on page 247, can we say that these two triangles are congruent? What do we say? Okay, so we have a side, 19 centimeters here. That matches to this side, 19. We have 20 matches to 20. This angle, though, between them, the included angle is 43. This included angle is 45. So can we say the triangles are congruent? No, we cannot. Okay, so not necessarily congruent. Okay. Angle A is not congruent to angle D. Okay. Let's take a look at the next one here. Letter B, looking at these two triangles. Do we have two sides and the included angle of one triangle congruent to two sides and the included angle of another triangle here? Yes. So are these two triangles congruent? Yes. So triangle, I'm going to be careful how I name this here. I'll start with J and then go along the 46-inch side to L and then K. So triangle J, L, K is congruent to triangle, and then how must, whoops, scoot this over here. How must I name this other triangle? If I started with J in this triangle, where do I have to start here? M, right? Very good. Yes. Thank you, Stephen, for that. Okay. And then from M, if I went from J to L, so from J to L was along the 46-inch segment there. So from J to L, I have to go from M to P, and then the last one's got to be N, right? Be careful how you name things. They have to correspond. Oops, sorry, I'm off the screen again. There we go. Questions on any of that? Easy, easy? Okay. So I think we've got that. We'll skip number 3, the your turn there, and we'll jump into a proof. Okay? So we'll skip letter A because I think it's kind of, well, I'll talk through letter A for us, okay, just because it's there. All right, so let's take a look at letter A. All right, so again, we've got given information, and we want to prove, okay. It says to just write each proof. Now, that means you can kind of choose how you want to organize your proof. Here, they're obviously giving a paragraph proof, right? They're not using a table. You guys can absolutely use the table with the statements in the left column and the reasons in the right column, stuff like that. But here we're told that segment BD is the perpendicular bisector of segment AC. You'll notice here that they put the perpendicular marker in there for BD and AC. What else can we mark congruent, though, in this diagram based off the fact that BD is the perpendicular bisector of segment AC? What else is going to be congruent in this diagram here? So, Jenny?
AD and DC.
Very good. AD will be congruent to DC. Must be. Right? Because BD is the perpendicular bisector of AC, so it's going to cut AC into 2 equal parts at point D there. Is there anything else we can mark congruent in our diagram here, just based off of how it's drawn? Jackson?
Angle ADB is an angle.
Yes, angle ADB is a right angle, must be. All right, so we have a side and an angle. Can we come up with another piece of congruent information between these two triangles? What else will be congruent between these two triangles? Avery? Yes, BD will be congruent to itself. Right? BD is congruent to itself. So, do we have side angle side congruence here? Yes. So there's our proof, right? We'd start by restating the given information. We would write Jenny's congruence there. AD is congruent to DC because BD is the perpendicular bisector of segment AC. Likewise, we would state Jackson's congruence there. Angle ADB is congruent to angle CDB because they're both 90-degree angles because BD is the perpendicular bisector of AC. And then finally, you can state Avery's congruence there. BD is congruent to itself by the reflexive property. And so we have side, angle, side is congruent to side, angle, side. The triangles are congruent. Okay, so this is side, angle, side. Okay. Could we have used angle, side, angle here if we wanted to with the given information that we had? Could we have used angle, side, angle? So if we're going to use angle, side, angle, how many pairs of congruent angles do we need? 2. Right, Jenny, 2. Do we have 2 pairs of congruent angles in this picture? I see 1 pair right here. Do we have another pair here? Can we say, is there a way we can say that angle A is congruent to angle C? Or is there a way we can say that angle ABD is congruent to angle CBD here? Do we have information to say that, Avery?
We could, but it would take longer.
Okay.
Because since the two sides, the BD and the AC are congruent, then the other side, AD and BC, they both have to be congruent, so one of the angles has to be congruent to the other. But by then, we've already proved that the triangles are congruent.
So I see what you're saying there, and I would agree with you. So the problem is AD and DC are absolutely congruent, but AD we don't necessarily know is the same as DB.
Well, we know DB and DB are congruent. So
Correct.
if 2 sides are congruent, the third side has to be congruent to the other one.
Not necessarily. Let me see if I can come up with an example of that. So, like, just knowing that 2 sides are congruent doesn't mean that necessarily the third side is. Let's see if I can come up with a convincing way to show that. Well, I mean, imagine if like we just had some like, you know, straws or something like that, and we like, or I don't even know, but if you like, if this is like a hinge, so like maybe we had like a, I don't even know here, like something, and they're just like joined here at their points, okay, like maybe 2 straws, and they're joined right there. I could open or close that angle so that I could create, you know, like this kind of triangle, or I could kind of create like this kind of triangle, or I could create like, you know, more like this kind of triangle. You see what I'm saying there?
Yeah.
So if so just knowing the 2 sides are the same does not guarantee that that third side will be the same, unless it's a right triangle. In that case, it would be. You know, unless we also know it's a right triangle.
Well, I guess since we've already proved it is a right triangle.
Right, and so that's the other thing too. I guess I see what you're saying there. Because it's already a right triangle, I see what you're saying. Because it's a right triangle, yes, then maybe could get away, yes, and come up with that, and it would be longer. You're right. You're right. But it would be important here that's a right triangle. It's true. Okay. In general, though, there's going to be one of these congruences that work. But I apologize. You're right. I see what you're trying to say now. Yes. Okay. Let's look at this next one. Okay. We have kind of a bow tie configuration going on here. So it means we're probably going to have some vertical angles going on. So let's see what we've got. So we've got segment CD bisects segment AE. So CD is bisecting segment AE. So that means what 2 pieces will be congruent here? If CD is bisecting AE, what will be congruent? Jenny?
AB and BE.
Good. AB and BE. Okay? With just that statement, CD bisecting AE, only AB and BE can be marked congruent here. We cannot say CB is congruent to BD. Okay? We're told that a CD bisects AE, but we're not told the other thing around, on the way around until right here. Okay? Now AE bisects CD, and so that means these two will be congruent as well. Okay? And then what other congruence can you come up with here? So, Preston?
Vertical angles.
Yes. Vertical angles right there at angle B, right? ABC, EBD. Okay. And so then these two triangles are congruent by side, angle, side, side, angle, side there, right? So they're congruent by side, angle, side. Again, I won't do that proof just because I don't feel like filling in their blanks. I don't like filling in their blanks, okay? But that would be the proof, okay? We would state the given, okay? And then we would have AB congruent to B. Oh, I guess we can run through it here. It's easy. So it is given that CD bisects AE and AE bisects CD. So there's your first statement there and the reason. So by the definition of a bisector, AB is equal to EB, and, well, CB is equal to BD. Okay? Which makes AB congruent to EB and CB congruent to BD. Okay? Angle ABC is congruent to, well, we just said they're angle EBD because they're vertical. Right? All right, and so two sides and the included angle of triangle ABC are congruent to two sides and the included angle of triangle ABD. The triangles are congruent by the SAS congruence. Okay. But again, there is no point where I will force you to do a particular kind of proof here. You are free to do whatever kind of proof you wish. Paragraph proof, it's up to you. I like the table just because I think it organizes things a little bit better. I think it saves a little bit of writing to do it that way too, but it's up to you. Okay. So let's take a look here at number 4 and actually do a proof. Do an actual proof here. Okay. So here in this proof, okay, we've got that AB is congruent to AD. So I'm going to go ahead and mark that on my diagram. AB is congruent to AD. We got that angle 1 is congruent to angle 2. So I guess I can go ahead and mark that and that. And then we're trying to prove the triangle BAC is congruent to triangle DAC. We have two congruences. Are there any other congruences we can mark here in our diagram based off of the way it is drawn? Anything else we can say is congruent in that diagram there? Okay. So Brandon, can you come up with another congruence just based off of the way the picture is drawn there?
AC is equal to
What's that?
AC is equal to AC.
AC is equal to AC. Beautiful. There you go. Do we have enough congruences now, Brandon, to say these two triangles are congruent? By what congruence? SAS, side, angle, side. You got it. Okay, so let's make our little proof here. Statements, reasons. So number 1, I'll just state both given pieces of information in one step. Okay, so AB is congruent to AD, angle 1 is congruent to angle 2, and what's our reason that we know that's true? Given. It is given. Okay. Brandon also said that AC is congruent to AC. Oops, I said CA, so I'm just going to roll with it. Okay. How do we know that something is congruent to itself? Reflexive property. We have 3 congruences. Now we can write what we're trying to prove. Triangle BAC is congruent to triangle DAC, and we have that side angle side congruence. There's an easy 3-step proof there. Easy peasy 3-step proof. Okay. Questions on any of that? All right. So that was side angle side. We'll assign some problems from that in just a little bit here, but let's turn the page to 255. And now I'll talk about side, side, side. Okay? So we have, again, angle, side, angle. That's what we learned first. We just talked about side, angle, side. And now we have side, side, side. Congruence. Okay? So if we have three sides of a triangle are congruent to the three other sides of a triangle, then we know that also all of their angles are going to be congruent too. Okay? Their angles will be, their corresponding angles will be congruent too. All right? So that's side, side, side. And again, you can, there's a little activity there. We don't need to worry about that, though. It'll be okay. Okay, let's take a look here at 256. Okay, at the bottom there, same kind of thing. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are the same. They're congruent. So looking here at example 1, are these two triangles congruent? Can we guarantee it? Yeah, right. We got 1, 2, 3 pairs of sides congruent. Okay. If we wanted to describe rigid motions that would show that they're congruent here, well, we could translate point A so that it maps to point D. Okay, and then we could that would get it to look like I don't know, something like that. Okay, and then we could rotate this triangle about point D until B matches up to E, and then reflect it up. Right? So that's one way you can kind of describe it there. We don't need to be very precise about that. It's okay. Just that, again, understand that rigid transformations map congruent figures to each other. Okay. Let's see here. Yeah, that's pretty straightforward stuff. I don't want to worry about that too much. Let's look at an actual. Oh, there's no actual proof in there. All right. Well, we'll jump to an actual proof here. Let's do. Oh, wow, there isn't one. I thought I did one before, but maybe not. Okay, well then, I guess I'll hold off on that then. I thought, Let me see what I've got in here real quick. See what I did in zip pass. Okay, I got an example for us here. I'll just show you one example of a proof. Okay, that's got, and I'll just do it in a separate space here. So let's use the space there on page 258. We got tons of space for that. So we'll ignore that piece. It's pretty straightforward. Duh. It's side, 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 right? They're all the same, or the matching parts there. So we can skip that. Okay. So let me give you this. So given triangle PST is equilateral and E is the midpoint of segment TS. Okay, oops, sorry, I'm off. There we go. Okay, so given that, we're going to prove that triangle PET is congruent to triangle PES. And I'll draw a diagram here in just a second. Okay. Now, of course, on a test or an assessment, you won't necessarily know which congruence you're going to use here. Okay? The book has already nicely organized everything for you, so when you're trying to prove something congruent, you're going to use the congruence that's in that section, right? Or the congruence that's for that section. But that might not be the case, right? So we want to, when we do, proofs, you want to kind of keep your eyes out, right? So you want to remember that side, side, side is a congruence. Angle, side, angle is a congruence. Side, angle, side is a congruence, right? And so this scenario, okay, let's kind of do it as if we're not really sure what congruence we want to use. So, in our given information here, we're not given directly any congruences. But can we pull a congruence out using some of this given information? Okay. So for example, can we use the fact that triangle PST is equilateral to give a congruence between these two triangles? Can we use the fact that E is the midpoint of segment TS to come up with a congruence between these two triangles here? Okay. So Jenny, what do you say?
That the segment SE is equal to
Okay. We're going to say they're equal. And what piece of information were you using to get that?
that E is the midpoint of TS.
Yep. So maybe we should start going to our proof for this. We can if we want. So statements, reasons. Okay, I'll go ahead and restate the given. Triangle PST is equilateral. E is the midpoint of TS. Segment TS, and that's given. Okay, and so Jenny just said we could say that SE is congruent to ET, and that's because E is the midpoint of TS. Or you could also just use like definition of midpoint there if you wanted to. Okay, so there's one congruence. And we use that E is the midpoint given information. What's another congruence that we could come up with here? We could state. What else can we say is congruent? Yeah. Madison, go ahead. Okay. Segment PE is congruent to segment PE by the reflexive property. Yeah. Very good. Okay, got that. And then Jackson?
PT and PS are congruent.
PT and PS are congruent. How do you know?
Because triangle PTS is equilateral.
There you go. PT and PS are congruent because triangle PTS, the big triangle here that's made up of the two smaller ones, it's equilateral. So PT and PS, those are sides of triangle PTS. They're going to be congruent. So triangle PST is equilateral. And no surprises here. What triangle congruence then can we use to show these two triangles are congruent? Side, side, side. So triangle PET is congruent to triangle PES by side, side, side. Okay? Questions on any of that? Questions on any of that? Alrighty. Very good. So that's all I've got to show you today, and now I'll get you guys some time to get started on practicing this stuff because, I think that's what really is what we need, some more practice with these proofs and things. Okay, so let me give you guys your assignments. We are going to be drawing from two sections here because we kind of went through two sections. Okay, so we're going to draw from two sections here. I'll get you that assignment in just a moment. Okay. So I'm going to have you guys do, starting on page 249, so that first section for the side angle side stuff. page 249, we have you numbers 2 through 8, the evens. And then 11 and 12. Okay. And then for the side. Starting on page 263, number 14, 15, 23. Yeah, I think I'll stop there. We'll just do that. Okay. Just that. Okay. For number 8, when you get to that one, it's approved. Just only focus on proving the triangle is congruent. You'll see what I mean when you get there. Okay, it's going to ask you to prove parts of the triangles are congruent. We'll worry about that in a second tomorrow. Okay, but today, just prove the two triangles are congruent there. Okay.
Sure.
Yes, you may. Okay. So that's the only proof that I really gave you there was that one. Okay. That's the only proof that I really gave you there was that one. So, yeah.
Mr. Ryan,
Yes.
so we're looking at point ABC is congruent to A at B.
Yes.
Okay, so and the middle part is not.
Correct. No, but you're going to use the fact that let me see. Let me go back. That hexagon is a regular hexagon, which means that the hexagon is both equilateral and equiangular and stuff like that. So that helps you with sides
Okay,
of some of the
so the
triangles.
same sides are all the same.
Yeah, the sides of the hexagon are the same. Yeah. Yes. Thank you, Sandy. Yep. Okay. Looks good. And then you can get one more page. Yeah, right there and there. Great. Did you want to look over your homework? You want me to give you the answer key so you can check your homework and stuff?
Sure. Yeah.
Real quick. If you want, you can take it back to your seat to look at, but that should be it, I think. I did some extra ones. I gave you. So obviously you don't. If you miss, but yeah, you know what to do. So look at the ones you need and move on from there. Yeah. So, okay. All right. Okay. Very good. Thank you. Yes.
All the angles and sides are congruent. That means that, right?
Yeah. Of the hexagon. Yes. I see. I'll be right there, Jenny. Sorry, 1 second. Okay. I think we can manage this. This is what we will do. We can do it, yeah. Right. What's that? Okay, so what one more piece of information should he measure? What other? So right now we have a situation so that he's going to get side angle side. But what could he measure instead to result in an angle side angle? So two angle side angles. So yeah, angle A, side A, so down side. A and D. Showing that A and D are congruent if okay, so are you always going to prove but I want you to really just focus on this triangle.
9
So
home
that
and 10
triangle.
away. Or 11. Depending on how far away it is. That's alright. That was one.
So you're not trying to do that? Okay, so you give it a dimension, right? So polygon A, B, C, F is okay, so if this, oh sorry, if you want to do that step, go ahead. Don't worry about that. Again, just show that the triangles are scalar. So like do ABC is R2, where's that triangle?
So regular hex.
I did this already though.
Okay. So we'll hold off on saying what it is. So what we say, so what does it mean for a polygon to be regular? It means it is both equilateral and equiangular. Correct. Do you want to state that for yourself? Because okay. So what else do we say is like? Well, let's say angle A, the full angle, is congruent to all three of those, but we don't know about the pieces. How do you know? Very good. Yes, how do you know? Yes. What else? So what? Well, I'll let you, but what you're trying to, you have to yes. So there you go. I think you can finish off the rest, right? Just state those other building there.
It's like you did, I didn't like it.
Yes, well, I realized they actually, I want you to show this. So we'll talk about that tomorrow. That basically is just adding one more step on your proof. When you want to, like, basically, here's the, once you prove the triangle are congruent, for example, here in this case, side. Once we prove congruent, that means all the parts are right? So while in our proof, only show that three pieces of information are given to three different information. Once we have that congruence established, we can then, for one additional step, say that since the congruent, AC must be equal to AE because they're corresponding parts, right? AC matches AE, so they will be equal because corresponding parts of the congruent triangles are also equal. That's the next step. One more step. Once you show the triangles are congruent, then you can then say any of the corresponding parts.
I know all of that.
Yes. One more step. Yep. And we abbreviate corresponding parts of the congruent triangle are congruent by CTAs. So, how about that? Those are delicious.
That's not confusing.
Regular means something actually very special. Equilateral and equiangular simultaneous.
Oh, so that means that all of these angles.
Yes. Got it?
So how would you know that pointing is angle? That's line.
I know. Well,
That's why I was really.
so the giveaway is that there's a degree symbol there.
Oh.
Now, granted, sometimes these books do have errors and stuff like that, but that's not my wait a minute, because also, if all we have is that these two angles must be equal, these two sides are equal, well, so that would, they wouldn't be, we're trying to. That's why I was like, wait a minute, and I looked at it, oh yeah, there's a degree symbol there. That means angles. But I agree, that is a little confusing. Yep. Well, I mean, that's legit though, because there's two angles, so the third angle would have to add up with that to make 180 degrees. I mean, in fact, everybody eventually, so I mean, yeah. So what now? No, not necessarily. Especially since I'm only asking if the triangles are congruent. Proving that.
She's you make